Welcome to Optical Communication Lab. First we will go through the syllabus. In Optical Communication Lab, 25 marks of term work and 25 marks of oral practical is there. In this way the total marks is 50 marks. There are some suggested experiment list from Mumbai University. Calculation of numerical aperture, calculation of dispersion, calculation of link loss for given link, performance analysis of single mode fiber, performance analysis of optical link with different sources, and so on. And the last experiment is calculation of link loss. Very important note here, a small project can be considered as a part of a term work. Now how term work will be calculated? At least 8 experiments including 2 simulations covering entire syllabus must be given during the laboratory session batch wise. And apart from term work, the practical will is also there, and the practical and oral exam will be based on entire syllabus. Let's start our experiment number 1. The aim of our experiment number 1 is calculation of numerical aperture. As you already studied in theory, what is numerical aperture? It is a light gathering, collecting ability of an optical fiber. Numerical aperture also refers to the maximum angle at which the light incident on the fiber and is totally internally reflected and is properly transmitted along the fiber. As we all know, numerical aperture is nothing but it is related with acceptance angle, but when we consider acceptance angle with refractive index of air, core and cladding, it will become a numerical aperture definition. Now the same thing which I discussed in the previous slide is represented in the form of a diagram. You can see here the acceptance cone where two angles are presented, alpha and alpha, and that full angle will be called as full acceptance angle, which is 2 alpha. And below you can see the numerical aperture formula, which is sin alpha or square root of n1 square minus n2 square. In the figure you can see that inside the fiber theta c critical angle required for total internal reflection, n1 and n2 core and cladding refractive index. Let's see how our experimental setup will look like. I have presented here 2 images. The upper one is the close and the bottom image is a far view image. In the first figure, I am starting from the left hand side. The source is there which will convert an electrical signal into light. That light will pass through an optical fiber and at the end side. Okay, so remember here you are not converting your light again into electrical signal at the receiver side because you want to project a light on a plate. That plate is a very important component in our experiment setup, and you can see here red color spot is there in the form of circle, and we are going to measure the diameter of that circle. And also you can see that the plate is moving. Okay, so we can move that plate, and after movement, as you all know, after movement the spot size is going to increase, means diameter will increase. So our complete experiment is divided into 4 to 5 steps, and these steps are nothing but we are moving our plate away from a fiber end, and because of that the spot size will increase. In the below image you can see a complete setup where the function generator and sources is also there. Now I am talking about the plate, and that plate is represented here in front view form. It will give you clear idea. 4 circles are there, and in left hand side image you can see that the plate is exactly parallel with the fiber end, and there is a distance L. So 4 circles are there, and our aim will be to transmit our light in the particular circuit. For example, we will start with the step 1. The light will incident in the first circle, which is having a very lowest diameter. At that time we will measure a L, distance between the plate and the fiber, and then we will move our plate far away from a fiber end, and it will be projected into a second circle. Say at that time also we are going to measure the diameter and L between the plate and fiber, and in this way we will cover the 4 circles one by one. And whatever we observe, we analyze, we will tabulate it in the observation table. You can see here the 3 steps are presented. We are going to perform 3 or 4 or 5 as per our need to get the better perfection or to get the accuracy. So diameter and distance we are going to measure, and after that we are going to calculate a numerical aperture. One thing is there, the numerical aperture formula which we studied, we are not going to use it here because we don't know n1, n2 and theta a. The acceptance angle we don't know. We are doing reverse engineering here. We are going to calculate acceptance angle after getting a numerical aperture. Means what? we should know about N1 and N2, but we don't know N1 and N2 also here. So which formula we are going to use? We are going to use this formula. See here. The third one, Na is equal to sine tan inverse of D by 2L. Sine tan inverse of D by 2L. What is D? You can see second last line. D is the diameter of spot on the screen and L is the distance between the output end of the fiber and the screen. Okay students, so here we will take help of virtual lab. What is virtual lab? Virtual lab is an initiative by MHRD, Ministry of Human Resource Development, and it is designed basically to do your practical remotely. In VLab, the website is www.vlab.co.in. You can go and find out the experiment for all the engineering branch, electronics, computer, mechanical and civil. The electronics and telecommunication branch, all the subject experiments are there. Okay, so I am showing you the screen of optical fiber VLab, which is handled and taken care by IIT Bombay. I will share a link in the description. So here you can see that measurement of numerical aperture of optical fiber. The four things are given there. You can see the emitter, okay, and the fiber stand, then fiber and a plate which we are discussing about on which the light will be projected. So experiments are very simple. Let's I select emitter first. Just you have to click on it. Emitter is placed. Next, emitter fiber stand. I have clicked it. Two stand comes because to carry a fiber, two stands are required. Next step will be take a fiber. Now fiber comes. Now after that, what is required? Screen. The output screen. I have clicked it, and screen comes. Now my setup is ready. Now you can see here emitter, fiber stand, fiber in between stand and screen. Now I am going to click on start. Now you can see here my setup is running now, and you can see a green color circle is coming. That is nothing but a spot, and our aim is to measure the distance between the fiber screen, the screen and fiber, and diameter of this circle. So two things we are going to measure here. So you can see here you have two options to select the fiber. There are two options are given: fiber cable and glass fiber. I will keep fiber cable, and I will change the length between the fiber and the screen. Now the distance is 12 mm, okay, and for that distance, what is your diameter? That will be displayed in a message box. What is the diameter? 13.33 mm. So your distance is in millimeter, your diameter is also in millimeter. Now I am going to put all this value in an observation table. For 12 mm 13.33. So for 12 mm 13.33. Now I will go to the next step. Step 2. What is that? I will change the length between the screen and fiber. Now the length is 16 mm, and what is the diameter for that? You can see in the message box 17.77. So for 16 mm 17.77. 17.77. Now step 3. I am again going to change the size. Now it is 19 mm. The 19 mm distance between the fiber and screen will give you a diameter 21.10. 21.10. So for 19, 21.10. Now the last step, fourth step is there. 20 mm. For 20 mm, I am getting diameter of 22.22. For 20, 22.22. Now after that, after getting all these reading, you have to draw a graph, and graph is of two axes, one on x-axis diameter in millimeter and one y-axis length in millimeter. So I will draw a graph. You can see a very linear graph comes. Then last step, okay, the last step is the formula we studied, which you are going to use here to calculate numerical aperture. What is that? Na is equal to sine tan inverse of d by 2l. So here you are having a 4 readings. So respectively, one by one you have to put all these 4 readings in that formula, and you will get your numerical aperture for 4 times. And after calculation, your numerical aperture will be 0.48 something. Okay, so I will just verify it. Yes, it's a 1% error. It's almost equal to our theoretical value. Okay, hope you understand this part. Now after that, we will tabulate all that readings. I have tabulated here, and the numerical aperture and acceptance angle, and the numerical aperture is 0.4 mm. Now what are the precautions we are going to take during practical? The optical fiber cable should be free from twist and fold so as to avoid the power loss. Connection should be proper and tight. What are the important questions for VIVA? What do you mean by refractive index? What is the difference between reflection and refraction? What is the basic principle of propagation of light in an optical fiber? Hope you are now know about the practical of numerical aperture. Thank you.